The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Alrighty, so eventually today we're going to wrap up section 10.4. But first of all, I want to do a quick review of yesterday, and then I have some questions from students. All right. So if we have a function in the form y equals a times the quantity x minus h squared plus k, the following things are true. The axis of symmetry is at x equals h. It's an equation, x equals whatever number h is. The vertex is at the ordered pair hk, and if a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. Also, if a parabola opens upward, the vertex is the minimum value of the parabola. If a parabola opens downwards, the vertex is the maximum. So this would be the minimum, this would be the maximum of the parabola. All right, do you have any questions about that before we go on? Okay. Let's take a look at the equation, the function f of x equals 5x squared. Is that in this form? Well, yes, it is. If we think of it as y equals 5 times the quantity x minus 0 squared plus 0. So where would the vertex be? It would be at 0, 0. Anytime you have a second degree equation that has just the one term on the right, only the x squared term, the vertex is always going to be at the origin at 0, 0. Okay, now let's find a second point that's on this graph. We know that the origin is the vertex. Let's pick another value. Let's say that x is 1. Well, then f of 1 would be 5 times 1 squared, which is 5 times 1, which is 5. My point being this, here's what we know about this parabola. We know that it opens upward, okay? We know that the vertex is at the origin, and we also know a second point, 1, 5. So what we're going to do in WebAssign is we're going to open up that little square that has the parabola until it turns blue. We're going to click on 0, 0, and then we're going to click on 1, 5. So we're going to do the vertex first, and then a second point, and that should produce the graph. Now, having said all of that, I want to take a look at a particular situation in WebAssign. So this is number 9 in section 10.4. And here we have f of x equals 5x squared, all right, which is the one that I just looked at on the white screen there, or whiteboard. So here is 0, 0, the vertex, and here is the point 1, 5, okay? So putting those 2 points in there would produce this initial graph. Now, as you can see, this problem has an x, so everything here isn't correct. But what is correct, this middle graph, and then the 2 graphs that are in green. And let's see how we get those. Okay, this second one, g of x, says it's equal to 5 times x plus 7 squared. So how does that differ from this one? Well, there's a plus 7 on the inside, so that means we're going to go 7 units to the left. So if we start here and we go 7 units to the left, we get the vertex of the new parabola. But consider this, The only thing that's changing is the whole thing is shifting to the left 7 units. So instead of 0, 0, and 1, 5, I'd have -7, 0, and then I'm going to go over 1 and up 5. Click, there's my second point. There's my graph, okay? Let's take a look at S of x. 5 times the quantity x minus 5 squared. So this means it's going to be the same shape as the initial graph, but it's going to go to the right 5. So here's my vertex, and I'm going to go up or over 1 and up 5, okay? Another way I could describe it is I could go back to this original one and take the 2 points and just go over 7, take this point, go over 7, take this point, go over 5, take this point, go over 5. Now, I don't know if you followed all of that, but I'm going to go back and I'm going to do another example. Give me a second here. Let's see here. So, student view and okay. All right, so now here is another example. Instead of it being 5x squared, it's 7x squared, okay? But let's take a look at that scenario. So first of all, I'm going to go back to my whiteboard screen again. And let's consider f of x equals 7x squared, okay? So the vertex is at the origin, okay? And then if I find, let's say, f of 1, that would be 7 times 1 squared, which is 7 times 1, which is 7. So I've got a vertex at the origin and then the point 1, 7. Any questions about where I got those 2 points? Okay, now, so to graph this thing, to graph f of x equals 7x squared, I'm going to choose the parabola till it turns blue. I'm going to go over here and I'm going to start with the vertex, which was at 0, 0, and then the point 1, 7. Okay, so there's my initial graph. Now let's take a look at g of x equals 7 times the quantity x plus 2 squared. So x plus 2 inside means it's going to go to the left 2 units, the inverse. So here I'm going to go over 2, and I'm going to go over 2, and there is my second graph. Okay, so everything gets shifted 2 units to the left. Let's take a look at the third function. S of x equals 7 times the quantity x minus 7 squared. So x minus 7 inside, we're going to go to the right 7 units. So from the original, I'm going to go to the right 7 units. I'm going to go to the right 7 units. And there are my 3 graphs. And let's see what that says. And they are correct. Any questions about this? So the point is, the only difference between this one and this one is it shifted 2 units to the left. The only difference between this one and the original is it shifted 7 units to the right. So you don't have to start all over. Just take the points you plotted and move them left or right, depending on what you're supposed to do. Okay. Any questions about that example? All righty. I'm going to go back to some other students' work here. Give me a minute. Let's see here. Okay. Let's see, 4770. And there. And 10.4 part 1. Starting with number 7. Okay. So this is still 10.4 part 1. We're looking at another student's work. This is problem number 7. Now, you might be looking at it going, well, the answers are already there. Yeah, unfortunately, in my view, it shows the correct answers as well as anything else that's been done here. So let's take a look at how we would deal with this, okay? So we've got f of x equals 1/6 x squared, and then g of x equals negative 1/6 x squared. Okay, so we're going to go back to my whiteboard screen. And again, that's in the form where the only term is involving x squared. So the vertex is going to be at the origin, okay? If x is 1, you'd have f of 1 equals 1/6 times 1 squared, which is 1/6 times 1, which is 1/6. Okay, so that's at 0, 1/6. Now, going back over here, and again, I can't work in this view because it's the student's view there, but this first parabola, 1/6 x squared, 1/6 is positive, so it's going to open up. Here's the vertex, and then we go over to 1, 1/6. Okay, I'm going to come back and look at this again in just a minute. Now, let's go back to the other screen. What's this going to look like? Well, it's going to look exactly like this, except instead of opening up, it's going to open down. So the vertex would still be at 1, 1, or 0, 0, excuse me, but when x is 1, g of 1 would be negative 1/6. Okay, so going back here, I know you're going to get dizzy going back and forth like this. You'd have 0, and then x is 1, or 0, 0 for the vertex, and then 1, negative 1/6. Now, I want to go back to the student view on that, or to a different screen on this, because I want you to see, again, to reinforce how you deal with fractions when you're graphing, okay? I've covered this in the past, but I want to cover it again here. Okay. Now, this is 1/2 and negative 1/2, but you know what I'm going to do? I'm going to cover that up, and I'm going to actually graph the one that we had originally, which was f of x was 1/6 x squared, okay? So that would be at 0, 0, and then 1, 1/6. Well, now, when I go to graph 1, 1/6, it tends to suck the point down to the x-axis there, which is not what I want. So what am I going to do? I'm going to come over here, and my first point was 0, 0. My second point was 1, comma. It was supposed to be 1/6. Okay? So see how I did that? Don't go to your calculator and put in 1/6 and get some decimal approximation. Put the fraction in there. And I also think it doesn't take mixed numbers. So if you come up with a mixed number, use an improper fraction, okay? So there's the first graph. Then the second one was also the origin, and then it was x is 1, y is negative 1/6. So here I'm going to go in and change that to negative 1/6. And there we go. So you see how that worked? Again, how you can come over here and you can fix the coordinates of the points. All right. Now, let's see here. We're going to go back to students. We looked at 7. I'm going to take a look at problem number 8. Now, number 8 actually starts with the same initial 1/6 x squared, right? So that's this middle one right here. Okay. Now, if f of x equals 1/6 x squared is this one, what if we have g of x equals 1/6 x squared plus 2? What does that do? It takes all of the points of this initial graph and moves them up 2 units. So instead of 0, 0, we're at what? 0, 2. Instead of 1, 1/6, we're at 1, 2 1/6. But the problem again, 2 1/6 is a mixed number, and I don't think you can put that in to WebAssign. I think it doesn't like to read mixed numbers. So what 2 1/6 would be what? 13/6 is what you'd put in for your fraction. Okay, is that making sense? Hopefully. Number 9 is just like the one I did earlier, except we've got 4x squared. So you got 0, 0, 1, 4. Then you'd move everything to the left 7 units, and then you'd move everything to the right 4 units. Okay.
Can we go back to number 8, please? That's the one I struggled with the most.
This one here. Okay. Let me do this. Let me go back to my teacher view here. So give me a minute. And let's see here. I want this. Sorry, it takes me so long to get between screens here. There. Okay. Was this one. Here we go. Okay. Is it okay if I use this example even though the numbers are different? Annabelle? Yoo-hoo. Annabelle?
I'm sorry, can you repeat what you said?
Yeah. Is it okay if I use these numbers rather than the 1/6? Or does it?
I would feel more comfortable with the 1/6.
Okay, okay. Then I'll just cover up the actual ones. And let's see, what was it? It was f of x equals 1/6 x squared. And then it was like g of x equals 1/6 x squared plus something. And s of x equals 1/6 x squared minus something. Do you happen to remember what the shifts were? Sorry, I didn't write them down.
The shifts between the numbers? Or
in other words, what was this number right here?
So that number is the same. It's just 2.
2. How about the next one?
The next one is -6 or -6.
Okay, okay. So let me get here. Come on there. So there's these 3 equations, right? Okay. So again, we've got the vertex is at 0, 0, and the first point is at 1, 1/6. Are we okay with how I got that?
Yeah, I mean, kind of.
Not sure. Okay, let's go back.
Yeah, not sure.
Let's go back. That's just fine. Okay. So this is of the form where A is 1/6, H is 0, and K is 0. So the vertex is at the origin. Anytime you've just got a single x squared term, so y equals something x squared, the vertex is always going to be at 0, 0. Okay?
Okay, yeah, I get that part.
All right. Now, if x is 1, f of 1 is 1/6 times 1 squared, which is 1/6 times 1, which is 1/6. Okay?
Oh, okay. I see what you did there.
All right. Now, So our first graph is at 0, 0, 1, 1, 6th. Okay? You all right with that?
Yeah, I get that part.
Okay, now let's go back. Rather than starting all over, which you could do, but it's more work and it kind of misses the point of this problem. In fact, let's see, let's get rid of this here.
So instead of doing more work, wouldn't you just take the answers from the previous problem and just add 2 to them, or am I wrong?
You've got it. That's the deal. Bingo.
Okay.
Okay? It's exactly what you do. Except this is going to need to be moved, going to be changed into 13/6. Okay?
Oh, because you can't put a mixed number in, right?
Yeah, let me try and see what happens. I just seem to recall that it doesn't work very well. So let me go back to this screen and we're going to go 0, 2, and then so 0, 2, and then 1. I want 2 and 1/6. And I think what happens, see, if I put it in there, it thinks I've got 21/6. Now, if I put a space in there, it won't even let me do that. Okay, so I've got to put in 13/6. Whoops. 13/6. Okay.
Got it. Thank you.
You bet. Let's just finish this one up. We've got one more piece of the puzzle here. So this, what's going to happen here? You're going to go down 6. So this is going to be -6. This is going to be 1/6 minus 6. So that's 1/6 minus what? 36/6, because you'd change this to, you'd have to get a common denominator. So this would be what? 1. And then the other would be what? -35/6. That's going to throw some people for a loop, having to add and subtract fractions. Okay. So,
Got it.
okay, let me just finish this up just for the sake of completeness. So we'd have 0, -6, and then 1. And I'm just going to put it there because I'm going to have to fix it anyway. And that's going to be -35/6, and bingo. What?
Okay. It was
Oh,
wrong.
that's right, because I didn't actually graph the ones that it says here. Sorry about that, because I was
No, you're
graphing the
fine.
1/6. So no wonder it's wrong. I'm like, what
Yeah,
happened?
mine came
Okay.
out right.
Okay. Now let's go back to, let's see. I think I was looking at, getting ready to look at number 17 was where we were at. Okay. So let's see what's going on here. It says determine the vertex and the axis of symmetry of the graph of the function. Okay, so f of x equals 1/6 times the quantity x plus 1 squared minus 3. We want the vertex and the axis of symmetry. Okay. Now, so if we think of the form y equals a times x minus h squared plus k, the vertex is at hk, so that would be -1, -3. The axis of symmetry is at x equals h, so that would be x equals -1.
Can you explain that a little more? That's where I really struggled. I don't understand the x equals h.
Yeah, neither do I.
Okay. Let's see here. I got my whiteboard screen up.
Yeah.
Okay.
Yes.
So if I have a parabola, and I'm just gonna go straight to the drawing of it. Let's see here. I've got this parabola. So the vertex is right here. The axis of symmetry. And one of the unfortunate things with WebAssign, they don't actually have you plot it. If we were in a regular classroom and I was having you do this on paper by hand, you would actually draw a vertical dotted line. This line right here is the axis of symmetry, okay? It goes through the vertex. So the axis of symmetry in this case is x equals 3. You see that vertical line through x equals 3. So the
Yes.
vertex is at 3 comma, in this case, 1. So when we go to the general description, the axis of symmetry is at x equals h. The vertex is at h, k. The axis of symmetry always goes through the vertex. It's always x equals whatever the x value of the vertex is. Is that clearing things up at all?
Yes.
Excellent. Yeah. And honestly, yesterday I had so much I felt like I had to do that I felt like I rushed at the end and didn't cover everything I wanted to. And I know it's really pushing it. That's why we have today to catch up. All right.
Can you say it one more time? Just the last like little chunk that you said.
The axis of symmetry always goes through the vertex.
Okay, yeah, got that.
If the vertex is at hk, the axis of symmetry is at x equals h.
Okay. Okay. I think I'm getting it.
Okay, we got one more and then we're going to get on to the new stuff.
Okay.
Which fortunately isn't that new. Okay, so we're taking a look at number 18 here. It says the height in feet of the water level in a reservoir over a 1-year period is modeled by the function h of t equals 3.1 times the quantity t minus 10 squared plus 18. Okay, now where t equals 1 represents January, t equals 2 represents February, and so on. So t is months, right? So January t is 1, February t is 2, March t is 3, etc. Okay? Do you understand that part?
Yeah.
It said the height in feet of the water level in a reservoir. So h is the height in feet. So t is time in months, starting with January is t equals 1. Height in feet is h, is the output. Okay? Now, it says, how low did the water level get that year? How low did the water level get? Okay, I want to go back to my whiteboard screen here. This parabola, since a is greater than 0, is going to open upward, correct?
Yeah.
Which means the vertex is going to be the lowest point. Okay? Now, if we had this on a graph, this axis is t, this axis is h of t. Okay? This is like x and y. So this axis is time in months. This axis is the height. So when would the water level be the lowest? At the h value of the vertex. When would that occur? At the t value of the vertex. Well, the vertex is at what? 10, 18. Do you see how I got that from this equation?
Yeah.
So this is T, this is H. T is the 10th month. Let's see, that's October. H is the height in feet. That's 18 feet. So going back to the WebAssign problem, let's see. How low did the water level get that year? 18 feet. When did it reach the low mark? In the 10th month, which was October. Does that make sense?
Yeah.
But you got to read it. You got to read it carefully. It says here the height is in feet. Time is months, okay? Because a common mistake is students will get the numbers and they'll switch them backwards. They'll say that it was the 18th month and it was 10 feet. I don't know what the 18th month would be, but so you got to really read carefully, identify what each variable stands for, okay? All right, we're going to go on now to the second part of this whole thing. And what I want to do to start with is I want to review again that if we have an equation in this form, the axis of symmetry is at x equals h, the vertex is at hk. If a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. Let me make a slightly better picture, okay? So we've got all that information. And how do we graph it? We identify the vertex, we identify one other point, we plot the vertex, then the second point in WebAssign, okay? Now, we're going to look at a different form of a second degree or quadratic equation and use it to find the same information, okay? That form is this, y equals ax squared plus bx plus c, okay? That's the, I was going to say standard form, but different books call them different things. That's the form that we use for the quadratic formula to find a, b, and c, okay? When our equation is in this form, the axis of symmetry is at x equals negative b over 2a. The vertex is at negative b over 2a, comma, f of negative b over 2a. And I know that seems kind of complicated. I'm going to come back and explain it. If a is greater than 0, the parabola still opens upward. If a is less than 0, the parabola opens downward, because either form, you're going to have the same value of a. Okay, if you take an equation that's in one form and put it in the other form, it'll still have the same value of a. All right, so this is the information we're going to use. Now, let me apply that to a problem. And let me get one here. Let's say we've got this. F of x equals x squared plus 4x plus 5. Okay, so that is in the form y equals ax squared plus bx plus c. A is 1, b is 4, and c is 5. Okay, now the axis of symmetry is at x equals negative b over 2a, which is negative 4 over 2 times 1, which is negative 4 over 2, which is negative 2. So the axis of symmetry is at x equals negative 2. Okay? Any questions about that? So that means that on my graph, there would be a vertical dotted line if we were graphing it going through x is negative 2. Okay? Now, the vertex is at, and let me show you what I had here, negative b over 2a, f of negative b over 2a. Well, remember, the x value of the vertex is the same number you got for the axis of symmetry. So that's negative 2, okay? But how do you find the y value in this case? Well, let's say you're trying to find any ordered pair and you know the X value. What do you do to find Y? You take it and you plug it in. So you'd find f of -2. That's what this is saying. You find the X value and then you find f of that. So what is f of -2? It's f of -2 is -2 the quantity squared plus 4 times -2 plus 5, which is 4 minus 8 plus 5, which is 1. So the vertex is at -2, 1, which would be right there. You following? So we're getting the same information, but we're using a different form. We're still getting the axis of symmetry first, but we're using this instead of HK, or instead of X equals H. And then we're finding the vertex by plugging that number in for the X, plugging it back into the function to find the Y value. Once we've got our vertex, pick an X value that's like on one side or the other. So maybe X is -1 and find f of -1, plug it in here, get that completed ordered pair, go to the graph. Okay? Now, a couple of other things I want to add to that though. And before we do that, let's take a look at another one. It says f of x equals x squared plus 4x plus 4. We're also going to find X and Y-intercepts. If you'll recall, back with linear equations, to find an X-intercept, set Y equal to 0. To find a Y-intercept, set X equal to 0. The same is true for quadratic or second degree equations. To find X-intercepts, set Y equal to 0. To find Y-intercepts, set X equal to 0. All right, so how would we find the X-intercept? We would set Y equal to 0. So we've got 0 equals x squared plus 4x plus 4. Okay, now, how are we going to solve this? We're going to use the quadratic formula. A equals 1, B equals 4, C equals 4, X equals -B, plus or minus the square root of B squared minus 4AC all over 2A. X equals -4 plus or minus the square root of what? 16 minus 16 over 2. X equals -4 plus or minus the square root of 0 over 2. X equals -4 plus or minus 0 over 2. So X just equals what? -4 over 2 or -2. So the X-intercept is at -2, 0. In this case, I just got a repeated root. I might have come up with 2 different X-intercepts, but I only came up with 1. You okay with that? How do you find a Y-intercept? Set X equal to 0. Well, what's f of 0? That would be 0 squared plus 4 times 0 plus 4. So the Y-intercept would be at 0, 4. So here's X-intercepts, Y-intercepts. Now, how would you find the axis of symmetry in the vertex? You'd use X equals -B over 2A to find the axis of symmetry. You'd plug that X value in to find the vertex. Okay, so we're still doing the same thing with this new formula. Okay, this thing right here. We're still finding the axis of symmetry in the vertex, but we're also finding the X and Y-intercepts. And again, to find the X-intercept, set Y equal to 0. To find the Y-intercept, set X equal to 0. Okay, I want to take a look at some story problems. Okay. Here is a problem. It says operating costs. The cost C in dollars of operating a certain concrete cutting machine is related to the number of minutes in the machine is run by the function C of n equals 2.2 n squared minus 66n plus 655. For what number of minutes is the cost of running the machine a minimum, and what is the minimum cost? Okay, now, first of all, this is a second degree equation. Its graph is going to be a parabola. Its leading coefficient is positive, so our graph is going to be a parabola opening upwards. Okay, the vertex of that parabola is going to be an ordered pair in the form n and then C of n. N is the input, C of n is the output. And let's see here. What does it say? So the cost in dollars of operating a certain concrete cutting machine. So C is cost, is related to the number of minutes n. N equals number of minutes, okay? So the number of minutes is the input, the cost is the output. We want to know for what number of minutes is the cost of running the machine a minimum. So we want the minimum cost. We want the minimum C. We want the C value of the vertex. Well, let's find the vertex. X equals negative b over 2a. B is that, and a is that. So it's going to be negative that over 2 times that, which is 66 over 4.4. And let's see, 66 divided by 4.4 is 15, okay? So n equals 15. What's C of 15? 2.2 times 15 squared minus 66 times 15 plus 655. I'm going to punch all that into the calculator. Let's see, minus 66 times 15 plus 655. And I come up with 160. Okay, so the minimum cost was $160, and the number of minutes was 15. Okay, so my answer went back to the vertex because it asked me for the minimum cost and the minimum time. I was looking at a vertex that was at the bottom. If it had asked me for a maximum, I would have been in trouble if my vertex, if the parabola opens upward. Okay, I don't know if that's making any sense. Let's take a look at another example. This says a fireworks shell is shot straight up with an initial velocity of 120 feet per second. Its height S in feet after t seconds. So S is feet and t is seconds. So S is feet, distance, t is seconds in time. The height S in feet after t seconds is approximated by the equation. S equals 120t minus 16t squared. If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? Okay, first of all, let's put this thing in its proper form with the t squared first. Okay, so what is A? A is negative 16. If A is negative, this graph is going to open downward. Okay, now what are the variables? T is the input, so this is T, and S is the output, so this is S. So if we find the vertex of that parabola, we'll know the time at which it reached its maximum height, and we'll know its maximum height. The T value will be the time, the S value will be the maximum height. So again, we're looking for the vertex. Well, let's see. A is -16 and B is 120. X equals negative B over 2A, which is -120 over 2 times -16, which is -120 over -32. Let's see, which is 3.75. So time, I know I used X because that's sort of the general formula, but time is 3.75. That's seconds. Now, how would I find the height? I would put time right there and right there. So S equals -16 times 3.75 squared plus 120 times 3.75. I know I'm going quickly, but fortunately you can go back and watch this at a much slower pace. And I get 225. So my vertex is at 3.75, 2.25. So the time is 3.75 seconds after it was shot, and the maximum height is 225 feet. So it said, how long after being fired? 3.75 seconds. Find the height at which the fireworks appear in the sky, 225 feet. So these story problems in this section all have to do with the vertex, but make sure you've got the right variable with the right thing. Again, a tendency is to get the numbers backwards. Make sure you figure out which one's T and which one is S, etc., etc. Okay. I've got 3 more minutes. I'm going to take it. This says ranching. It says, see the illustration, and let me just draw the illustration here. What we've got is we've got this fence, and there's this river, okay? And it says a farmer wants to fence 3 sides of a rectangular field with 1,000 feet of fencing. The other side of the rectangle will be a river. First of all, I want to say whoever wrote this is not a farmer, because the river would not keep the cows in. They would get out in the river, probably drown or who knows what. Okay, but the point is we're building 3 sides of a rectangle. Okay, and the total number of feet of fence is 1,000. Okay, since it's a rectangle, we know that these 2 sides are equal. So then what's this third side? Well, if the whole thing is 1,000, let's do this. If the whole thing is 1,000 and we take off an X and we take off an X, what have we got left? We've got 1,000 minus 2X. So this piece right here is 1,000 feet minus the 2X. Okay. Now, what they want us to do is to maximize the enclosed area. Well, the area of a rectangle is the length times the width. So the area would be 1,000 minus 2X times X, or 1,000X minus 2X squared. If I write it in descending powered form, I get that. That's a parabola opening downward. My input is X, that's this distance. My output is A, that's the area. I want to maximize the area. So basically I need to find the vertex. X is negative B over 2A, which is negative 1,000 over 2 times negative 2, which is negative 1,000 over negative 4, which is 250. So X is 250 feet. All right. So this is what, 250. What's A of X? What's the maximum area? Well, we'd put 250 there and there. So we'd get negative 250 squared plus 1,000 times 250. And calculator time. Let's see, 50 times 250 plus 1,000 times 250, and I get 125,000, and that's what? Square feet. So where did it go here? It says if the enclosed area is to be maximum, find the dimensions of the field. So they would be 250 by, what's 1,000 minus 2 times 250? That's 1,000 minus 500. That's 500 feet. And the maximum area would be 125,000 square feet. Okay, I gotta go. Time's up. I'll be back at 1:15 if you have questions, and hopefully you'll have a good rest of the day.
Thank you.